Okay. Hello. What we're going to talk about today is we're going to talk about probability. You might be wondering why I'm about to have a piece of toast. Well, to be honest with you, I'm a little bit hungry. Like a bit of jam on my toast. There we go. There we go. Okay. So, probability. Oh no! Oh. And it's gone jammy side down. What are the chances of that? Ruined it. Hey, wait a minute. What is the probability of it going jammy side down? Does it always land jammy side down? It always seems to land jammy side down. So because I've just done that once and it landed jammy side down, does that mean that it will certainly land jammy side down? Let's try it again. Okay. Sorry. Jam there. No. Not that time. So how am I going to work this out? How can I get an idea of actually what the probability is? Jammy side down. 2 out of 3. Must be 2 out of 3. I think I need to do it more times. Let me just do it one more time. Oh! 2 out of 4. There you go. Evens. Well, do you think that's enough? Well, actually, I think I need to do it more times. So maybe if I do it 10 times, how many times should I do it to actually get an idea of what the probability is? I'm going to leave that with you. I'm going to come back to it in a minute. So come and join me at my little probability table here. So I've got here, I've got a regular 6-sided die. Okay. So if I were to roll this, now look, I've got a 2. If I were to roll it, let's say 300 times. If I rolled it 300 times, how many times do you think I would get a 6? Hey, there's one. 1. Right, don't worry, I'm not going to roll it 300 times. But how many times do you think I would get a 6 there? Well, there's 6 sides. So 1 6 for 300 is 50. Does that mean I would get exactly 50? Well, I would probably get 50, and I might get kind of a couple either side of that. Right, as long as I get reasonably close to 50. Okay, what about if I take a regular pack of cards? So if I just cut the cards, and let's say having a look at thinking about me getting a red or a black card, because there's red or black cards in there. So if I cut them, what have I got? Well, I've got a red card. Right, so if I were to do this 100 times, how many times am I going to get a red card? I should get it 50 times, but not necessarily 50 exactly. As long as I should get it pretty close. If I don't, then there might be something wrong with the pack of cards. Maybe there's more red cards than black cards in there, possibly. Or maybe there's something else going on. There'd be some sort of bias in there. So if they're not biased, it should, well, another red one. Right? I should get about 50 out of 100, but not necessarily the same number. Right. So my toast, how many times do I need to go through and actually drop my toast to get a good estimate? Do I do it 10 times, 20 times, 30 times, 100 times, 1,000 times? Now, I don't know about you, I don't really want to go and do it 1,000 times. That's going to take me a rather long time. So, we're going to come back to that question in just a few moments. In the meantime, so let's have a look, see what actually happened with the toast when we dropped it. So, but first of all, so we're looking at relative frequency. And so to find a relative frequency, it's the number of times the result happens divided by the number of times the experiment's done. And all relative frequency is really is it's just a way of, it's like an experimental probability. Okay, so it's basing your probability upon an experiment. And something else, more trials is always better. So the more you can do, the better the answer that you're going to get. So let's have a look at these just here then. Well, this is what happened when I dropped the toast. I didn't think you would want to see us actually dropping it 100 times, right? So after 10 goes, 6 times the jam side was down. Always seems to be jammy down. And you can see I just recorded the results over time, so you can see that there. So if I want to work out the relative frequency, it's 6 divided by 10. So that's 0.6. We've got 13 divided by 20. So 13, you can use calculator if you really want to. Right? And that's 0.65. 17 divided by 30. So 17 divide 30. 0.56 reoccurring, so I'm going to put 0.57 because I want to do it to 2 decimal places. That's an easy one, 0.5, and then 27 over 50 is 0.54, and then 0.55 after 100. I could have written all the ones in between there as well, but I just decided to record it at those points. Right, then the next thing I thought I'd do is go and take this information and go and pop it into a graph just to sort of see what that looks like. And let's have a little look over here to see what this appears like just here. Look. So I thought this would be interesting to see. Now I kind of got a little gap here because we had nothing recorded relative frequency wise below this point, so I kind of thought, well, let's start it from there, otherwise it just looks a little bit daft. So let's go for it and just plot these points. So at 10 we were on 0.6, and then we went up to 0.65, and then 30 we dropped down a little bit. So that's 0.55, so 0.57 is about there. 40 was 0.5, dropped right back down, and then it came back up again. Then we went to 0.54, so kind of in there somewhere. And then by the time we got to the end, it seemed to settle down on that point just there. So here we go. And then you can decide about whether you think there's more chance of it being jammy side down. Well, it is slightly above halfway. Okay, so like I said, that's what happened with my piece of toast. Now, surely if you were doing that as an experiment, I don't know, maybe you'd have to look at kind of how I was dropping the toast. Maybe there's a technique for it to land jammy side down more than not. So you'd have to kind of analyse exactly how that was done. I don't know, maybe the jammy side does that make it weigh a little bit bigger so it kind of sort of tips over? I don't know. But that would need some further investigation. Okay, that was the information that I had there, right? Just to give you the idea of what we mean by relative frequency. Now the other thing that we talked about was the dice. Okay, if you remember my dice, we had, I said if you rolled the dice, if you rolled it, let's say 300 times, you should get a 6 50 times. You should get a pretty even spread. So, but I rolled it 60 times, and this was the set of results that I got, which I kind of thought was interesting. So like I said, that was 60 times. I can check that because I should be able to add them up. Look, so that's 30, 40, 46. Yeah, comes to 60. Okay, so I thought I'd work out the relative frequency of each one. So a score of 1 is 12 over 60. Score of 2 was 3 over 60. 9 over 60, 10 over 60, 14 over 60, 12 over 60. Now there's one of those scores that stands out. Just one. Not the highest, although maybe it is slightly high. The one that's really bothering me is that one, just there. Because they all should come to about 1/6. 1 divided by 6. They all should come to about that figure just there, right? 0.16 reoccurring, like 1 divided by 6. So if I go and do some of the others, so for instance 12 divided by 60, that gives me 0.2. So that's not too bad. But let's look at this 3 divided by 60. Well, that's miles out. That's I said, yeah, okay, it's possible, but I think that die is biased. Okay, I think it's biased. So you need to look and try and think about fair or biased. Okay, right then. So let's get on and try having a go at a few.